I'm Levi Crosley.
I'm Gabby Jackson.
And I'm Jonathan Proctor.
And today we're going to be discussing experiment number 3, determination of a chemical formula. The objective of this lab is to synthesize and determine the empirical formula of a product of a reaction of zinc metal with a solid iodine to determine the formula of an unknown hydrate. The introduction to this lab would be, in part A, you will determine the chemical formula for a compound of zinc and iodine. And in part B, you will determine the number of moles of water in the hydrate. And the materials, you're going to need a beaker, a 50 milliliter and a 100 milliliter, a hot plate, and in this lab we'll be using a Bunsen burner, an unknown hydrate, a zinc metal, iodine, 0.2 m acetic acid, a crucible and the cover, a Bunsen burner, iron ring, and an iron stand, and a wire gauze. For the procedure, in part A, you're going to begin by 50 milliliter beaker. You're going to remove the beaker and add approximately 0.6 grams of metallic zinc into the beaker. Then you're going to record the mass. On a pre-weighed weight paper, you're going to need to measure about 6 grams of solid iodine and add to the beaker that containing the zinc. Record the mass of the added iodine and add approximately 5 milliliters of 0.2 acetic acid. Swirl.
Alright, now we're going to swirl the beaker and record what is seen. The reaction should be colorless and should take about 20 minutes to complete. Once complete, all the iodine will have reacted. The solution will contain aqueous zinc iodine and acetic acid. Then you're going to decant the solution into a clear, dry 100 milliliter beaker. After this, you're going to add approximately 3 milliliters of 0.2 molar acetic acid into the beaker. Swirl, then repeat previous step of decanting. Repeat above step again twice. Wash solid zinc leads with DI water 3 times. Discard DI water in collection bins. Dry remaining zinc and allow to cool. Weight beaker with zinc. Heat again for approximately 5 minutes. Mass again. If within 0.01.
Okay, and so now we're going to talk about part B of the experiment. The unknown hydrate that we have is either magnesium sulfate, zinc sulfate, or strontium chloride. And we chose unknown C to try and determine which unknown we had. The first step is to determine which salt we have or which number of moles of water is present. The first thing you have to do is mass a clean, dry crucible and cover and add approximately 4 grams of the unknown hydrate and then remass it. Instead of adding 4 grams, we added around half a gram though. We record the mass of the hydrate that was placed. Then we heated the crucible and cover with the lid slightly open in order to gently heat it and not let anything explode. If you hear crackling, remove the crucible and cover from the heat until it stops, then replace it back on. After 5 minutes, if no crackling is heard, you heat the hydrate more vigorously. You crank up the heat. After heating for a total of 20 minutes, you remove from the heat. Once your crucible is down to room temperature, you mass it, and then you heat it on high for another 5 minutes. Remove from the heat and allow it to cool. If you're not within 1/100 of a gram, repeat the step again. Pour a small portion of 6 molar hydrochloric acid into a small beaker. Light a Bunsen burner, then dip a spatula in the hydrochloric acid. Place it into the flame. Repeat until no color comes from the spatula in order to clean it. You place some of the unknown on the end of the spatula, and if you see a bright red flame, you have strontium chloride. If you don't see a bright red flame, you need to put about 1/10 of a gram of the unknown into a test tube and add a few milliliters of deionized water. Drop in some magnesium and we wait for approximately 5 minutes, and if magnesium is collecting on the strip, it's magnesium sulfate. If magnesium doesn't collect on the strip, you have zinc sulfate. We had zinc sulfate.
For calculations part A, we'll be calculating the moles of iodine. First, you're going to start with the mass over the molar mass. And in this experiment, we had 0.6 grams over 126 0.9 grams over moles. And that's the grams are gonna cancel out to give us 0.0048 moles of iodine.
Okay, now we're going to do the reacting zinc. So we're going to take 0.66 grams of zinc and subtract it by 0.49 grams of zinc, which is the reactive, or the remaining. And that's going to equal 0.17 grams of zinc. And then you're going to go and to get the moles of zinc, you're going to do 0.17 grams of zinc reacted over the molar mass of zinc, which is 65.38 grams per mole. And that's going to equal 0.0026 moles of zinc. And now you're going to do 0.0048 moles of iodine over 0.0026 moles of zinc, which equals 1.8, which is about 2. And this 2 right here determines your empirical formula, so it's going to be ZNI and N equals 2.
So now we're going to do the calculations for part B. And what we find is the mass of the hydrate minus the mass of the salt will give you the mass of the water. And in order to determine the mass of the salt, you take the crucible with the salt at your last burning and subtract the weight of the crucible. So with those two figures in mind, we find the moles of water equals the mass of water, which was 0.27 grams approximately, over the molar mass of water, which, as we all know, is 18.02 grams per mole. The grams cancel out, and you're left with 0.015 moles of water present. Then to find your moles of salt, you take the mass of the salt present, which is 0.58 grams, divided by the molar mass of your salt, which is 161.44 grams per mole. Once again, grams cancel out, and you have 0.0036 moles of salt. What you use that number for is you divide your 0.015 moles of water by your 0.0036 moles of salt, and that gives you a number of X, which equals 4.17, so approximately 4. So your unknown for the unknown Z, with our salt being zinc sulfate, our chemical equation will be Zn SO4 4H2O. And just some of the possible errors that we had, we could have not let the reaction in part A fully complete and had too much or too little of something mass-wise. And then some of the errors in part B could have been the amounts of the substances we used or our math and our measurements. Thank you very much.